So in this video, we will design something similar to validator error pings that we designed in previous section of creating validators using Spring dependency injection. And we'll write our first validator, as well as we'll write some reusable code which can be used by every validator to match the case that we are trying to check for. So now we are not using in tuples, we are not using Spring, right? So we cannot really use this code like pings and configuration. What we can use is this code. All right, so what I will do is I'm going to create something called as a class called as error datas, and it will be of course private constructor. It will just hold it will not hold anything, but everything will be static, something like this. So let me just copy all of them, and then I will go ahead and make sure that there are no errors and can be used from external this thing. So the third one, the final one, empty transaction. Okay. All right, now what we'll do is we need error data class also from there, right? Because we are using their error data. So we'll just I have it over here. I'll just plug it in over here. And error datas, what we have to do over here is we have to assign it to something like list of error data as no invoice, right? So we'll use from external, right? It should be public static final. So let's see how this goes. Public static final collections singleton list. Okay, just a static import. Right, moving on, let us write it for item not specified, means no item. Then for this one, amount is not specified, right? So no amount and no transaction, right? So now let us make a static import for this guys, also it looks better on the one single statement. All right, now we have these error datas. Right now we just have to use error data in our validator. So let us write our first validator, transaction request validator. Okay, so transaction request validator will be the name of the class, and the class, it will have one method called as validate, and it will accept a type of transaction. And what we will do now is, this is really interesting, right? So let me just give you an overview of what we are trying to do, why we designed tuple. So we have tuple type t1 and t2, right? And we'll say like let's say case 1, right? And we'll create a tuple like this, tuple2 dot of. So t1 will be a condition and t2 will be the error message if that condition is fulfilled. Like let's take an example, tuple1 dot of, tuple2 dot of transaction. If it is null, then say that error datas dot no transaction. That's it. So now what you have, t1 as boolean and t2 as list of error data. All right, so this is the first case, right? So over here, I mean, we can have multiple cases, right? So if this is the first case, let us just remove this. I'll just copy this thing like this over here. Like transaction is null, transaction dot invoice equal to null. Then let's say no invoice. If transaction dot invoice dot item equal to null, then let's say no item. And transaction dot invoice dot item dot is empty, then again no item, sorry, no item, right? These are all the tuples that we have, and we want to execute all of them in sequence, right? First one, second one, third one, and fourth one, right? In order to add and in order to execute them in sequence, we can just add all of them in a list, right? So we can do something like this. List dot off is a static factory provided in Java 9, like this, right? So just make a comma, this all will be elements, and the return type for this one will be list of tuple. So something like this, list of tuple, right? Let's say cases. Right, now our job is something like this. For just iterate through it, right? Tuple and cases, and if this returns true, that means we know that there was some error, like transaction was null. Let's take an example. Transaction was null and it returns no transaction. But if you see something over here, right, this for loop looks like a redundant, right? We don't really need to have this kind of logic in place over here. What if we delegate this responsibility to a different class? Okay, so let us try to design a class called as case, where the API would work something like this: case dot of this case is all the cases, and we'll say dot match, something like this, right? So if nothing happens over here, if no exception is thrown, which means validation was successful, else there was some issue with it, and we'll throw request exception. So let us create a class called case right now. Okay, case, and of course it will be R. I'll come back to that R later, but we'll write class like this: private case, and it will accept list of tuple 2. Input first element will be boolean, return type will be R. So list of error data, it can be anything, R can be anything. That is why that is what R is used for, right? So that's about it. And let us type private final list of tuple 2. Oh, let me just copy this thing, no point in writing that big statement, right? So we take this thing, this dot case is equal to cases, and let us start writing a static factory. So public static R case of R of this list. Okay, and return new case list dot copy of cases. Again, copy of is the method added in Java 10, which accepts collection and returns immutable copy of this list. Okay, and case of list, there you go. Now we want to write a match method. So public void match, and this is a really simple method, right? So you just write tuple 2, this entire list of element, tuple 2, and you say cases, and if tuple 2 dot t1, then we know that something failed. Then we say request validation. Okay, we need that class, so I'll just go and copy that class up. It should be an API request validation. Okay, so request validation exception tuple 2 dot t2 dot toString, right? That's it. So this class will handle it, right? And let us come back to transaction request validator. So this is it. If this condition matches, we'll throw this error. If this condition matches, we throw this error, right? It looks good, right? The only problem over here is this will not work. Okay, the reason behind that is, look at this condition: transaction equal to null, transaction dot invoice equal to null, invoice dot items equal to null. So this is evaluating the condition, right? So let us take an example over here, right? Main transaction request validator dot validate null, right? So ideally we would expect that equal to null will be executed and will return no transaction, right? but this won't be the case. This thing will throw null pointer exception because this tuple 2 dot of transaction dot invoice will also be executed, because by default the method evaluation is eager evaluation in Java, right? It is not lazy evaluation. So let us run this main method. Let's say proceed. See, main line number 22. Let's come to line number 13. It failed over here with null pointer exception, right? So this method was, this condition was evaluated even though we don't want it to be evaluated, right? So how can we really do that? So the answer to this question is to have a lazy evaluation of a condition. As soon as the condition is lazily evaluated, it will be evaluated only if it is needed, which means that we have to change tuple type as well as we have to make a little change in case class. All right, so how to do that, we'll take a look at it in the next video.